So this is the thing here, right? So we'll see the reactions based on aluminium. So aluminium has certain features, right? So aluminium has certain features. So if you see them, right, aluminium can react with air, right? With atmospheric air, It can react with acids, right? It can react with acids, and then you have base, right? It can react with base. It can react with ammonia, right? It can react with ammonia, and with some halogens also. React with halogens. Let's say it's. So why you see the aluminium's reaction? So we have air. In air, we have a major proportion of oxygen gas, and then we have nitrogen gas. So nitrogen gas has the prominent amount of prominent percentage here than the oxygen gas. So it has the highest amount of percentage in the atmosphere here, right? So aluminium can react with into gas to give aluminium nitride. So, so this is a balanced chemical equation. Same way, aluminium readily reacts with oxygen to form aluminium oxide here. So if you put here in this balance. So if you take acids, like for example, if you take when once aluminium reacts with, like for an example, let's say Cl here, it forms aluminium chloride and H2 gas. Right, it leaves the H2 gas, particularly here. So if you put 2 here and 3 here, 6, and then you have 2. For the base, same way aluminium reacts because aluminium can react with both acid and base, so therefore it is called an amphoteric metal group, right? So aluminium, so 2 aluminium, 2 OH minus, 2 H2O gives 2 aluminium and H2 gas respectively. So same way aluminium reacts with ammonia. It gives particularly again the nitrides, right? It gives the nitrides and then the H2 gas here. Right? So here you can put 2, here you can put 3, so 6. So you want to make the 6 2. So 2 nitrogen is here. Also with halogen. So if you put aluminium with Cl2 gas, you will get aluminium chloride again. So put 2 here, 3 here, this is going to be balanced here. So this is the reactions based on aluminium here. Right? So these are the cases which belongs to aluminium here. So if you take now what you're going to do is you're going to dissolve some aluminium in water, right? In aqueous state. Okay. We're going to put some aluminium in aqueous state. Now we have some aluminium in aqueous state. Now once aluminium is in aqueous state, right? In aqueous media, aluminium tends to form an equilibrium. This is a very important part, right? Tends to form an equilibrium here. So aluminium, once if it is in aqueous state, it forms aluminium, I mean hexa aqua, aluminium 3 plus ion, right? Aluminium 3 plus ion. So from this water, from one of this water, one H plus will be removed, right? So it will be reacting with water partially, it will form an equilibrium, right? It will be react with the under an equilibrium. So therefore, so here this aluminium come up within the uh, ligands here. One of the water will remove H and the OH will remain within the system of aluminium. So therefore, aluminium H2O 5 times, you will get OH minus, right? Here OH minus, yeah. You will get 2 plus, plus here, one of the water remove H plus now, that H plus will be taken by water to form hydronium ion, right? H3O plus. So again, this one again will undergo a dissociation, right? Again, one more water will break it. So therefore, aluminium H2O 5 times OH 2 plus will again undergo dissociation with water, right? It undergoes a dissociation with water to give aluminium H2O 4 times OH twice and again a hydronium ion. So this equilibrium will be there. It will happen as a cycle. It will be happening always within the system there. So this is the concept here, okay? So it will be happening as a cycle here. So let's say now this is going to be your, let's say this is happening within the vessel. Let's say this process taking within the vessel, okay? Within the aluminium aqueous media, right? What you're going to do is, right, just to check whether we have aluminium or not, whether we have any precipitates or something. So we got already know this is aluminium. Yeah, we need to form some kind of precipitate. So what I'm going to do is, I'm going to add some amount of OH minus. Let's say some amount of OH minus. Let's say few drops of OH minus, right? So I'm going to add some amount of OH minus, yeah, which means like sodium hydroxide, like it can be potassium hydroxide, it can be barium hydroxide or strontium hydroxide. All those hydroxides are strong there. So after adding, okay, after adding some case here, this aluminium, right? This aluminium will take that hydroxide. This aluminium will take this aluminium complex will take that hydroxide. It will take the hydroxide, right? This aluminium hydroxide. So did you note down this reaction? Huh? I'm going to raise this part. Did you note it down? Okay. Right. This aluminium complex, right? This aluminium complex, aluminium is 2O 4 times OH minus twice plus, there's going to be a plus here, right? Here you're going to have a charge plus here. Plus, it takes another OH minus. Then it's going to precipitate. So it will precipitate as aluminium hydroxide to form, yeah, it forms aluminium hydroxide as a precipitate. Right? I just add only a few drops. So as a result, some precipitate came. So aluminum hydroxide came. And this water completely will be removed. 4 months of water will be completely removed. Since this process took place here on this complex, now here this amount will decrease. Did you finish physical chemistry? Lee principle? Did you finish concepts? Any concept on physical chemistry there? On chemical equilibrium and all? Okay. So you haven't reached that part. Okay, I'll just give a small explanation. Okay. Now the system is peaceful right now, right? Now the system is going to be peaceful. What I'm going to do is I'm going to grab this fellow, right? I'm going to grab and drop to precipitate here. So now what will happen is this system, right? If once you say equilibrium, it will happen in a cycle, okay? It will be happening in a cycle. So this cycle, what will happen? This cycle will be disturbed. Let's say now this is the cycle here. So some amount of water will be going here, and then to balance the side, this reaction takes place and come here. That's why we have put this equilibrium sign here. What I'm going to do is now this is the product here, right? This is the product here, right? Let's say this P, and here we have reactant. So this is happening in a cyclic process. This product, this is the reactants here. So this is the product side and reactant. Here we have the equilibrium symbol. Okay. So in the product side, what I'm going to do is this cycle is here. I'm going to grab some products. So by precipitating some aluminum hydroxide here. So here our product is aluminum hydroxide. So we took this product from this cycle here. So what will happen is this fellow cycle will be disturbed here. This product side will be reduced here. So therefore this reactant it tends to put more this complex here. You try to put some more complex to balance the initial step. Understood? Initially we had some amount of this complex now. So since we had some hydroxide, this precipitated. Okay. So this complex will move towards that side to fulfill the remove part there. So this will keep precipitating. So this cycle will move front. So this thing is coming from here now. Understood? This complex is coming from here now. So therefore it will pull the aluminium oxide also this side. So both the cycles will be taking place. So it will pull all these people to the right hand side. So therefore this particular fellow's concentration will decrease. Do you understand what I'm saying? You want me to explain it again? Did you understand? So therefore this complex will move front. It will try to fulfill the removed amount of aluminium here. But this aluminium complex will be going here. This aluminium complex will be precipitating as aluminium hydroxide. So some amount will be precipitated. So this will move front to reduce the concentration in order to balance this equilibrium here. Okay. So this is the concept. You will study this deeply in KSP part. So this is from KSP, but you need to know the law of Lee-Chatfield principle that is coming after the equilibrium. Chemical equilibrium. So this is the basic concept here. Just said any normal tip of the leaves, right? Just like a cow grazing over tip of the leaves, right? So this aluminum hydroxide features are, this is a white color, gelatinous. It is gelatin. It looks like gelatinous PPT. So this is a white gelatinous precipitate, right? So this is a white gelatinous precipitate. Okay. What I'm going to do is I already had some amount of hydroxide now. Now what I'm going to do is in the second case, right? This is for the first case. So I kept adding some few drops and few drops. Then all of a sudden what I'm going to do is I'm going to put excess OH minus, right? Excess OH minus. So in this case, once I add excess amount of NaOH, this aluminium hydroxide, right? This aluminium hydroxide will take that OH minus in excess to form AlO2 minus, or it can form, you can write in this manner also. So this is a complex here. So this one was initially white gelatinous precipitate now. This white gelatinous precipitate. So this white gelatinous precipitate will go to colorless here. So which means aluminium hydroxide can react with excess NaOH. Like for example, excess NaOH or excess KOH, any strong acid or strong base to completely dissolve to form this complex. So it will go colorless. So this is readily dissolves in excess OH minus. Understood? This can react with excess OH minus. Right? So this is the main case here. Right? So this can form this kind of complex here. Understood? Did you understand this case here? The equilibrium case. What happens when aluminium hexa aqua aluminium 3 ion is there in water? You understand the case? Right. So this thing is also the case here, right? But once you consider any OH minus, there are two types. There are two types of OH minus. That also I'll explain. So we have strong OH minus. We have strong OH minus. Let's say strong base. You have strong base, and then you have weak base. We have weak base. So in strong base, we have the first group and second group bases. We have barium hydroxide and then strontium hydroxide as strong bases, and then you have sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. All these people are strong bases. Yeah. So first group people. So lithium hydroxide can also be considered as strong base. So all these 6 people are strong bases. So once you consider weak base, we have only one, that is ammonium hydroxide. So ammonium hydroxide is a weak base, right? Ammonium hydroxide is a weak base. So once ammonium hydroxide, right? Once you have ammonium hydroxide, this ammonium hydroxide will partially dissociate. Will partially dissociate to give ammonium ion and OH minus. So in partially give. So if you add ammonium hydroxide, let's say if you put ammonia into this solution, right? You can get the precipitate here, right? I will surely guarantee you can get the precipitate. Once you add ammonium hydroxide to this fellow, obviously you will get this white precipitate here. But if you add excess ammonium hydroxide, you will see only this color. You cannot see this white precipitate will dissolve. You will never see an observation where this white precipitate will dissolve once you use excess ammonium hydroxide. Understood? Because this is a weak base. So weak base, in a sense, even though if you add excess amount, there you cannot completely dissolve it. But once you add strong base like barium hydroxide, strontium hydroxide, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, any one of them in excess, this particular fellow has a tendency to form this complex here. Understood? Right. So this is the case here for the aluminium here. Right? So this is the thing. Okay. Now see, as I said, 13 group has NS2, NP1 as their electronic configuration. So they have NS2, NP1. Right? NS2, NP1 electronic configuration. Right? So we have for 13 group, we have NS2, NP1 electronic configuration. So they have 3 valence electron to form bonds with the other substance, other elements there. Like for example, if you take chlorine, let's say reactions of aluminium with chlorine forms. So it forms aluminium chloride. Two, right. DC balance getting. So we have aluminium chloride here. So once you consider the structure, let me draw the structure. Once you draw the structure of aluminium, right? Once you see this chlorine octet role is fulfilled here. This chlorine is also okay. This chlorine is also okay. But once you check the aluminium, once you check the aluminium, right? Once you check the aluminium, there's going to be a problem there. Why? Since they are having the electronic configuration as NS to NP1, since they are having NS to NP1, they are having 3 valence electrons there in their outer motion. They are having valence electron, 3 valence electron in their outer motion. So as a result, the case is like it can form only 6 here. So this is absolutely not possible actually. This cannot stay under normal condition. It is unstable. So what most of the 13 group elements, even though if you consider aluminium, gallium, indium, tellurium, all these people are electron deficient species. We say this people as this compound as electron deficient species. Because they did not, the reason is because the octet rule is not fulfilled. The octet rule is not fulfilled. Okay, so this is the case here. So in order to overcome this problem, okay, in order to overcome this problem, I'm considering aluminium chloride here. Let's say now we have another aluminium chloride here. Let's say now we have another aluminium chloride. So we have another aluminium chloride here. So from this adjacent, right? From this adjacent case, so this is in gaseous state. This is happening in gaseous state. So now this chlorine has lone pairs now. This chlorine has lone pairs. This lone pair will be donated to this aluminium here. Understood? This lone pair will be donated to this aluminium. This lone pair, either one of this lone pair will be donated to this aluminium here. So since this donated means this is plus, since this took means this is minus, same way applies here, plus and minus. So now this complete structure, right? Now if you write the formula, this is going to be forming bonds now. What kind of bond is this? Can you say me, what kind of bond is this? Simple general chemistry question. What kind of bond? This is called a dative covalent bond. This is a dative covalent bond. Why? One species within the particular molecule donates in order to fulfill the electron octet rule. So as a result, this chlorine donates B. This forms plus and this forms minus. So therefore, this is a dative covalent bond. You can ask me like whether this is neutral or not. It is neutral. Why? This aluminium is minus. Since this chlorine donated, it became plus here. So therefore, what happens? If you take the summation of overall charges, it's going to be 0. So obviously, since in order to form the stability, this structure is called a dimer. So they can ask in the essay part also, like X is a particular compound. For example, X is a particular compound. It forms compounds with halogen, and under gaseous state, it forms dimer. So obviously, we should know X belongs to 13 group, which means electron deficient group, right? So electron deficient group, they tend to form dimers there in order to fulfill the octet state, because aluminium chloride cannot stay alone. So therefore, it is really unstable there, right? It is really unstable there. Same way, if you see the equation itself, you can get the answer, right? See, 2 aluminium chloride here. So therefore, this is forming dimers here. So the it forms dimer in gaseous states. In gaseous state, it forms dimer in gaseous state. So what is the formula here? Al2Cl6. So this can be asked in the future structure or essay part. So this is the stability of 13 group elements in gaseous state. So they form dimers to fulfill their octet rule. Understood? So this is the whole part of 13th group here. Okay, are you clear? So this is the whole concept behind the 13th group. Nothing else. So within this area only they can ask the questions. What all the characteristics they can ask, whether is it possible or not. So all these concepts come under here. Okay, so we'll try to finish up the next question here. Right. So in the sixth question, we'll see the sixth structure question. Right. I'm raising this part. So the 13th group concepts behind the theory part concept is already being cleared. Right? Are you clear with the concept? Is it clear? Because I haven't missed any parts, I think so, because I explained the total concept there. That's the concept behind the 13 group there. Only aluminium is there, nothing huge. We'll see the 15 group once you come to the essay part. So I will discuss it again. Right now, see, write the balanced chemical equation for the reaction of X when heated NaNO3 and dilute NaOH is used. So sodium nitrate. So sodium nitrate, I'll just take NO3 minus. So nitrate ion and the basic medium. Like they have put on the basic medium, now they have put aluminium there. Keep in mind, this is this is an identification test for nitrates in the 15 group. So if you have a nitrate, you can do this kind of experiment. There are lots of experiments there. So once you add aluminium metal along with hydroxide in the basic medium for the nitrates, so you can also say aluminium as so in the past paper they have given this one as It's like Devara alloy something. Yeah, they have said like Devaraj alloy. Like Devaraj alloy. I'm not sure with the word, but I can understand. Like remember, it's like Devaraj alloy, 2015 or 2014 in the essay part. So we can say this one is also Devaraj alloy. So if they ask Devaraj alloy, it is obviously aluminum. Okay. So once you add nitrate, once you add aluminum to nitrate in basic medium, it obviously forms ammonia gas, right? It forms ammonia. This aluminum will form aluminate, and this hydroxide will go to water here. I'm not sure. We'll try to balance this part. So ammonia, sorry, a nitrate goes to ammonia, aluminium goes to aluminate. So this one is reduction because this is -3, this is +5. It went +5 to -3, so therefore reduction. This one went from 0 to +3. This means oxidation. So oxidation, reduction and oxidation. Yeah? So it balance both the sides. So nitrogen is okay. So we balance water here. So here you need this side you need 3 water in order to balance the oxygen on the left hand side. See on the right hand side you have 3 and here 2 into 3 6. So 6 plus 3 you have 9. So our in the right hand side we need 9H plus. Right? We need 9H plus. And now we will balance the charges here. Everything is okay, we need balance the charge. So if you subtract here, you will get around 8 you need 8 electrons to neglect the charges. Same way, if you apply the same case here, you need 2 moles of water and 4H plus and then 3 electrons here. Right? So if you are able to multiply this equation by 3, if you multiply this equation by 8, right, you can get the equation balance. So 3 9s are 27H plus 3 nitrate plus 2 in 8 16 water 8 aluminium. Now on the right hand side 3 ammonia plus 9 H2O plus 8 aluminate plus 4 HR32 H plus. Right? Now we'll balance this part. So here we have 27H plus. So you can cancel this out. So 27H plus. And here you have 32. So to neglect. So this is an acidic medium. Still, let it come to the basic area. I'll show you how to do it. Okay. So 27H plus. Here 32. So 3. Here 5H plus will be remaining here, right? So here 5H plus will be remaining. Same we will check for water. If you cancel here, you get 7 water remaining. 7 water remaining. So still we will finalize this equation. Now they said this is a basic medium now. So what we like just like maths. Now how much H plus we need? How much X plus is there on the right hand side? You should put that same amount of same amount of for 5H plus you need 5 OH minus, okay? So therefore if you put 5 OH minus over here, same in the opposite side you have to put 5 OH minus there. So if I put 5 OH minus here, I have to put 5 OH minus over this side. So therefore, if 5H plus and OH minus comes, so 5 water will come. So you can cancel this water and this water, so you get 2 water remaining. So finally, this is the basic need. So write the residues here. So you have 3 nitrate, 3 moles of nitrate plus 5 moles of OH minus plus 2 water plus 8 aluminium. And then you have 3 moles of ammonia and you have 8 moles of aluminum. So this is the balanced chemical equation for the nitrate here. Okay, so as I said, this is an identification test now. So this ammonia will be evolving here. This is the observation. Ammonia will be evolving here. So in order to test whether this is ammonia or not, right? You can get the smell, but smell is actually not suitable because most of the disgusting, awful smells are really toxic there, right? Very much dangerous. So therefore, if you can see, right? You can see this ammonia, you can test them up. So you can hold a jar, right? Like downward displacement of air, you can take the ammonia there. We take the ammonia, right? Sorry, upward displacement of ammonia here, right? You can supply ammonia in a glass jar in this manner. What you do, take some HCl, and what you have to do, take a glass rod and you have to dip that glass rod into the considered HCl solution, right? So if you take them out, some drops of HCl will be there, right? So if you put that glass rod into the jar which is filled with ammonia, there we can see white fumes. Some white fumes will be formed. So that white fumes are caused due to the reaction between ammonia and HCl. So it forms ammonium chloride, which is a white fume there. So it forms white fume. Or else you can do, take a bottle cap, dip into the HCl part, not the inside part, the top part, the smooth area, the closing top part. So dip that one into the HCl and then dip in, then just put inside uh, the ammonia gas there. So there you can observe white fumes in the bottle cap. So bottle cap test is also possible, but this is more accurate, more safe also. So therefore, this white fumes is caused due to ammonium chloride. So this causes white fumes. There is one more way. There is one more way. If you take ammonia, if you take this gas and if you bubble them into the